everyone. Welcome back to New York Energy Week 2024, the epicenter of global energy innovation, where industry leaders, pioneers, and visionaries gather to shape the future. This landmark event, now in its 11th year, unites the brightest minds to forge a new path and challenge the conventional boundaries of energy technology and sustainability. So thank you for joining us here on the One Business Pro platform for our transformative journey that promises to inspire, empower, and catalyze groundbreaking advancements in the energy sector. So joining us now this morning from Vancouver, Canada, is James Walker. He is the CEO and head of reactor development at EnerKnol Nuclear Energy, which is a publicly traded company. And his topic is creating the next generation of advanced nuclear fuels and developing smaller, cheaper, and safer portable clean energy solutions. Good morning, James. Welcome.
Good morning, Glenn. Thanks for having me on.
All right, let me hand it off over to you, and I will join you on the backside here. Thank you.
Okay, great. All right, well, thanks everybody for tuning in to watch this. And I'd like to walk you through a little bit about our company, how we got started, and the things we're working on and the direction we're going in. So a little bit about us. We did start as a microreactor company principally, but as we were obviously looking at producing a commercial product for industry, we began examining that supply chain and involving ourselves in different aspects of it just to de-risk the business. And I'll touch on a little bit in each of those aspects that we're currently working on. But the idea now is to try and have nano involvement, our company's involvement in each stage of these things, so we have a more competitive product that goes out the door, as well as being able to generate revenues in other businesses that can expand the business and de-risk the company overall, even before the microreactors come online. And we'll go into a little bit of each of those items as we go through. It's probably just a bit important to touch on why this is a very unique time for nuclear. So as people have probably noticed, the Department of Energy and the government are putting a lot of money back into nuclear power. And it's principally because there was a reliance on Russian material that was coming in from abroad. And because of that reliance, it didn't need such a robust domestic manufacturing system to get the fuels out there. So now that obviously relations have broken down with Russia, the US is looking to build back those capabilities. But this is also coming at a time when there's big industries like the tech industry that are looking at nuclear as well to be able to solve a lot of their energy issues. And so they're looking at nuclear for things like tech centers, AI centers, data centers, and these are very energy intensive systems. And for that reason, the tech centers are piling in, but there are also other industries like big mining companies that have these decarbonizing mandates. And in a lot of these remote locations, there's no solution other than nuclear because you can't just site whatever power system you want wherever you want. Whereas nuclear, you do have that ability. And so there's almost this two-pronged approach that is really accelerating the interest in nuclear power. And it's why there's so much development and there's sort of this resurgent industry that's occurring at the moment. And so our company was obviously very well timed. We entered the market before there was this sort of resurgent interest. And now we're obviously being able to build within a very robust and quickly expanding industry. So the reason why we went for microreactors over small modular reactors, and just to break it down very quickly about the difference, is that a small modular reactor is really classified as anything from 20 megawatts up to, could be anything, 400 megawatts as an example. And a microreactor is something from 20 megawatts and below. But when we were looking at the landscape, we realized that with SMRs, they're a wonderful product, but you still have to compete with conventional power system, conventional energy sources. So gas, because you're powering conventional grid systems. So gas, coal, oil, even wind, solar, even big nuclear. Whereas microreactors, the only competition they really had was diesel generators in remote locations. And these diesel generators had really had no competition. But because they're obviously in remote locations, that daily importation of fuel means that that fuel is actually very expensive. So to create a nuclear product like a nuclear battery that competes with these remote systems becomes much more economically feasible. And just to bolster that idea as well, is that microreactors were the much less developed technology of the SMR and microreactors. And so we pushed into that area because we believed it was the less competitive landscape. There was the larger industry too, because these things could power island communities where there are hundreds of millions of people across the world, military bases, mining sites, remote industry, remote habitation. You could adapt it for maritime vessels, all of these different areas where you could deploy these microreactors to, and they could effectively, without diesel generators, not have any competition from more other conventional sources, even renewables that people are trying to push into would not be suitable for a lot of the environments that you could send these to. So based on that premise, we thought we needed to make a very consumer-friendly product. And so we looked at what the final consumer would want. And we knew we had to be able to get these microreactors anywhere in the world. And for that reason, we confined the dimensions to an ISO container size. So they had to be able to go on the back of a truck, a ship, or be shipped by train. And so we started with that ISO container constraint. But around that, we said it also needed to be able to be not just portable, but passive cooling, very few working parts, needed very few people at site. And ultimately, what we wanted to do was sell the energy and not sell the product, because customers would be more interested in buying energy than they would be interested in running their own reactor, decommissioning their own reactor. We could keep ownership of it and sell the power. And from our feedback and from our industry research, that seemed like the much more, not just innovative, but much more appealing products that we could be selling to customers. And so we went out and we started recruiting the best scientists we could find in the world for this. And fortunately, there are a lot of professors and engineers and scientists at universities that were already beginning to look at this as a conceptual idea. So one of the first reactors we started working on was done with professors based out of the University of Berkeley, California. And we gave them that MO, the dimension constraints, passive cooling, very few working parts. And they came up with a very novel solution of completely removing the primary coolants from the reactor itself. And that shrunk down the reactor enormously because pumps weren't needed, pressurizers weren't needed. And they operated moving heat through thermal conduction through a solid core. And then you had a very, very safe, and I say very safe because there's very few mechanical components in there. So routes to failure were very much reduced. And even if every component was to break in the reactor, it would still have that passive cooling mechanism where you couldn't get the big accident scenarios like core meltdown that you can in a big reactor, as an example. And so we've obviously begun pushing into developing that. And we're now working into the test phase of this reactor. So we're going to be building out rigs and nuclear and non-nuclear rigs and collecting that data we need to go for licensing. And just to de-risk our company, we decided to bring in a secondary team. And the number one team we could find in Europe was professors based out of the University of Cambridge in the UK. And we gave them the same MO as Zeus, and they had a very different solution, but also very complementary. They were looking at a high TRL components, licensed fuels, and using a salt to remove that primary heat. Again, passive cooling mechanism, very simple technology, but also because it was using those high TRL level technologies and off-the-shelf components, the licensing period could be, very much reduced down to its bare minimum that we could get away with to get these as a commercial product out the door. So one thing I think that's interesting about the company is as we began to start building out these microreactors, and we were looking at de-risking the company, it became quite clear that because of the US reliance on this Russian fuel in the past, that the supply chain was somewhat insufficient to be able to guarantee that we would have this fuel we needed to build these reactors. And we even saw this with some of the big SMR companies, that they're really going to struggle with sourcing fuel. We didn't want to have those issues. So we've involved ourselves in trying to be involved in the different supply chain aspects. And one thing we brought up with the Department of Energy and the national labs was, when we talked about the supply chain, is that they recommended straight away building our own fuel fabrication facility with a deconversion capability. And they said that because one, it would obviously de-risk our fuel supply, but two, it would also give the country an ability to source fuel from us that they would need for their own microreactors and SMRs. And so we've now identified a site for the reactor, for the fuel fabrication facility, as well as we've built the design team now. And now that we've closed the IPO and we're moving into a different stage of development, we've already started work on the design features with regard to the facility and the different fuel forms that will be manufactured by this facility. And as we started to build this out, the DOE was obviously taking interest in where the fuel was going to come from this next generation, and they set up a HALEU consortium. And because we had already started down this route, we became one of the founding members of the DOE's HALEU consortium. One critical thing that we identified as another issue is that we could produce commercial quantities of HALEU fuel, but we weren't confident that we could move enough HALEU fuel for our anticipated reactor business. And what I mean by that is, say at the moment you cannot, the regulations do not allow for anything to be critically configured and moved. And that means reactors themselves, as soon as you fuel a reactor, it becomes critically configured and you can't move it by road. And there's obviously some moves underway at the NRC to try and adapt the regulations to allow for that, but we want to work around existing regulatory framework. And for that reason, that means putting the reactor at site and then fueling it there. And those are the designs we've worked around. But that also means that we have to be able to move fuel to the reactor in as few loads as possible. And since we identified that, we realized that the Department of Energy had invested a significant amount of money in technology that was developed by ORNL, INL, and PNNL, the three major nuclear labs. But the funding had been cut to that. So we bought the exclusive license to that technology with the intention of building that out so we could move commercial quantities of fuel around the country for our own business and also for other companies that were interested in deploying reactors, fueling them. And it's a revenue generating business that could come online before our microreactors. Another aspect we've become involved in as well is that because this resurgent nuclear industry has come about so quickly, we've also looked at how we're going to source enough people. And so with the, in combination with the Cambridge Nuclear Energy Centre, we're looking at putting in programs, masters, PhD programs, as well as technical qualifications, so we can ensure a steady supply of personnel to be able to do everything we want to do in the business, and have the personnel we needed to expand as quickly as we needed to expand. So this is something we've already started, and we should have a steady stream of graduates as a result of this. So just to summarize the different aspects that we're working on currently is that we will start rendering some consultancy services this year. So we'll get into revenue this year, but that's a business we're going to build up over the time of the company, because there is a shortfall of personnel, and we were expanding very quickly, and we have that personnel to contract out. So to people that need help, obviously establishing themselves and doing work. We anticipate the fuel fabrication, the fuel transportation products and services that could come online next, sometime around about 2027, 2028. With the fuel fabrication facility coming online sometime around about 2028, 2029, just in time for our microreactors to be ready around about 2030, 2031 as well. So different lines of the business coming online, one, de-risking what we're trying to do completely, but also creating that supply chain to be able to produce that competitive final microreactor product for the wider industry. One thing I'll touch on very quickly as part of this is that we tried to build up our connections as best as we can. We are talking to people in the Army at the moment and the Air Force about building nuclear reactors for their bases, and part of that as well is having people on board that can help us do that, such as 4-star General and Supreme Allied Commander Wesley Clark. But also as we begin to work through government contracts that we're looking to initiate now, having people like Bob Gallucci, who's the former negotiator of the North Korean missile crisis, is a very important aspect. So we understand the political aspects of working in partnership with the US government. And we've even brought on recently former New York Mayor Andrew Cuomo, because they were also looking at, he was involved in the decommissioning of Indian Point. But since then, I think he's to try and pursue other renewables. But since then, even then, he's looking at energy solutions for the states of New York, and very well connected to be able to move us into the right circles to be able to establish ourselves within the provision of energy for high level projects. And combined with that as well, we've talked a lot with African countries. In fact, we should have some announcements coming out in the next couple of months with regard looking at energy solutions in Africa. And part of that as well is people like Lazini Zorbo, who is the former president of Burkina Faso, that's connecting us with groups that can identify projects in remote locations within Africa that are off grid, but also looking that need desalination, vertical farming, power for medical facilities. Microreactors could really unlock a lot of human capital and bring a lot of better qualities of life to people in remote locations. And the last one I'll touch on here is David Huckaver as well, who's joined our board as well to help with things like the fuel transportation business, the former executive of UPS. We're obviously it's very beneficial to have someone with that level of experience. And when you're entering these sort of industries that, as a nuclear engineer, I'm not as experienced with. So I think in conclusion, we're a very diversified and de-risked company that's obviously tried to focus very clearly on commercial products and creating very competitive product. We've tried to structure ourselves in exactly the right way as well. And we've entered the market early to grow with the public and provide the investors with a chance to be part of this sort of nuclear renaissance that's occurring at the moment. And I think you're seeing sort of a very positive reflection in the market with regard to our company, because we have taken this tactic. So anyway, so that's our company in a summary. I'm happy to take any questions, Glenn. So.
Okay, thank you, James. Congratulations for all your good work. Congratulations on the IPO to you and Jay as well. So you're still pre-revenue then at this point in the cycle, correct?
We are, yes. So we're about to enter revenue in a few months when our contracts begin to start. We obviously lined them up many months ago, and we're working through the details of those contracts. But the important part is we want to get into revenue quickly, and we want to expand that business. So part of that consideration is also going to be acquisitions. So we've been buying technologies that we know we can license out commercially. That's one aspect to it. But the other one is too, we are looking to, because we want to build our workforce while combining that with revenue, we're going to be making some very strategic acquisitions with revenue generating companies. So we have that additional capacity within our company. So we don't want to be just market dependent or grant dependent or anything like that. It's a very risky strategy. We want to go a very different route and be very independent.
Yeah, in any entrepreneurial venture, the whole concept of moving to commercialization becomes often one of the most important parts, for sure. Very
Yes.
impressive board of executive advisors. Runs the spectrum from talent, for sure.
Yes. Look, it's obviously been a very great privilege working with people like this. I also should mention we recently lost our head of advisory board, Governor Richardson, Bill Richardson. He was the former Secretary of Energy, but unfortunately he passed away in recent months. And but actually, up until then, he was a great asset for us, and I think instrumental in connecting us with the right people to make sure that we had the right personnel involved to be able to really launch the company effectively. And we have some other very big names, I think, joining the company in the near future, and obviously that'll be another announcements to come. So.
Did the movie Oppenheimer give you any buzz?
It did, actually. I've got to admit, we benefited from that movie a lot, and funnily enough, actually, we've grown quite close with the grandson of Oppenheimer, Charles Oppenheimer, and yeah, so we've met up with him several times, and he has some low level of involvement in the company as well. But what was interesting in the movie is that where the nuclear industry began was actually in Berkeley and Cambridge, which are the two technical teams that are working in nano. So watching it, it was kind of a very different thing now that you're working in the company, and you can see that, oh, we're working with Berkeley, oh, we're working with Cambridge, and oh, we know Charles Oppenheimer.
Yeah. You go where the talent is, you go where the history is, and you're surrounding yourself with some really talented folks. Now you've got Zeus, and then you had Odin, right?
Yes.
Zeus, you said you ran through, so you got the U.S. patent trademark office. You're working through that, and then Odin. Now that different focus, same type. You said low pressure coolant reactor versus the battery reactor. So two different kind of ways to go about the path forward, correct?
Yes. So originally, actually, it was part of a de-risking technique. So we wanted to have two avenues to success in case one failed. But what ended up happening is that as the models proved them both feasible, we realized that they were actually fairly complementary because the Zeus reactor is a higher temperature reactor. So for applications like commercial heat and processing heat, the Zeus reactor is much better suited for. But for the Odin reactor, high level TRL components, cheap materials means that you can mass manufacture these items much more easily with things like 3D printing techniques. And they could power things like accommodation, electric vehicles. And so you could actually deploy both reactors to the same site to work in conjunction with each other. And for this reason, we've decided very uniquely to pursue both avenues. So we can cater to both markets.
Now in both images on the slide, they're on trucks, right? So they are portable. So you just reference it. So you can go to the site, right? It's not so much, it's not new construction, it's not permitting, it's all of those things that you talk about Indian Point that you go through in a traditional type of sense. So talk about the portability. What makes that so important? I mean, it sounds like it would be a lot much quicker to market once you're up and going.
So that was the intention. If you want to build a microreactor, you have to be able to get it to these remote locations. And so, if you want to build an SMR-sized system in the middle of nowhere, you're looking at a lot of deliveries, a lot of infrastructure projects, and it's going to be very costly. So how do you avoid that cost? Well, you have to have your whole system, so your reactor system and your conversion system into electricity within one vessel. And that can put enormous amounts of constraints on the power you can get out of a core, for instance. But if you are competing with diesel generators, that's a very feasible thing to do. And especially if you're supplying energy over 15, 20 years, you beat out the economics of a diesel generator very, very competently. But so we obviously had that constraint. It needed to be able to move by road or by train or by ship, and effectively even needed the ability to be able to helicopter it in if you needed it for things like disaster relief areas. So the idea is if we can come in and put the reactor down and plug into a microgrid with as little preparation work as possible, then you can start making an economic product. If you have to start building large infrastructure in the middle of nowhere, especially Arctic conditions or anything like that, you start killing the economics of it. And I touched on Africa as an example of where this could be shipped internationally, but these locations are very remote where there's no access to energy. But if you ship these things in, there are microgrids there for diesel generators. So can you just plug it in straight into a microgrid and go from there? That's the intention here. And if we move away from that model, then you start to begin complicating the economics around the deployment of these reactors. So it's a very important aspect to have that portability there for this.
I mean, who would have ever thought that nuclear power would be plug and play, right? Pretty fascinating. Nuclear, I mean, you mentioned Indian Point again. I'm here on Long Island. We had Shoreham, and we kind of went through this whole cycle. And here it is now, you come back to a sustainability kind of focus, and it's now once again there as a potential opportunity to be tapped into. And they do it around the world for sure. And here we are now seeing it in the forefront, which is pretty fascinating from just a history lesson standpoint.
Agreed. And this is something interesting too, because the US has effectively already deployed microreactors because there are several dozen universities in the US that have had their own test reactor operating since the 60s or before. So we know this can be done, and we know it can be done safely because these things are still in operation even now. And now we're just going to do it on a commercial scale for industry as opposed to universities and research institutions. So it should be a very exciting time. It should be fairly revolutionary with regard to the energy space. It should, and certainly in remote locations, island communities, disaster relief areas, make lives better. So it's not, obviously it's a wonderful business, but it can have a very beneficial and positive effect outside of that too.
Oh, for sure. You're growing the good throughout the communities that are affected. Especially you think about disaster relief, for sure, bringing that kind of power in. How about from a regulatory standpoint? How do you, a lot of changes, stable? How do you guys stay up on top of it?
So obviously there's been engagement with the regulator. Effectively at the moment, they're actually trying to look at streamlining their own processes, and there is political pressure on them to do that. Because they don't want, obviously, the regulatory process to be in the way of this sort of resurgent industry, especially if you consider that countries like China have more nuclear power in the pipeline than the rest of the world put together, because they're going all in on nuclear power. They need to be able to sustain their wealth generation, and the way to do that is power. There's no such thing as a energy poor, rich country. And the US is obviously wants to do the very similar thing. And so obviously the negotiations with the NRC and telling them of our timelines and the personnel we'll need. The current process involves sort of a 40-month process, but they're even looking to try and streamline that for microreactors, because a microreactor is a very different beast to a gigawatt power station. Much fewer working parts, much fewer methods to failure, far fewer people needing to be involved in the operation of that reactor too. And so it's, even though they're both fission, they're still very different products. And applying one regulatory framework to the other one isn't exactly suitable. So they are looking to try and change things to make life easier for us. But how quickly they can move, we'll see. But we've even started our own investigations into proposals for the NRC so they can stick to existing regulatory frameworks, but also license our reactor within a reasonable amount of time and cost. Because if you're going over 4 or 5 years, you could run up hundreds of millions of dollars in cost for a review process that might not even be suitable for you. So
you're helping them become more nimble as we go.
Oh, yes, I'm hoping they become more nimble, and we're going to try and help them do that. So
Absolutely. Well, listen, James, thank you for joining us on New York Energy Week. Fascinating discussion. Congratulations on the IPO. Best of luck here as you continue to move forward, getting to that commercialization process, and congratulations for surrounding yourself with the great set of advisors, scientists, and people like yourself, and best to you and Jay in the future.
Wonderful. Thank you very much, Glenn.
All right. Be well. Take care.
You too. Bye.
Thank you.